Hi everyone, welcome to Numeric Learning. In today's video, let us solve chapter 1, exercise 1.3 of NCERT Exemplar book. The very first question is, prove that root 3 plus root 5 is irrational. So whenever you have to prove irrationality, the method that we use is called as contradiction method. Okay, so the very first thing that we would write it, let's assume that root 3 plus root 5 is rational. Okay, so instead of, what do you mean by rational? Any number that can be written in the form of p by q. Okay, now instead of writing p by q, for simplicity, I am going to write root 3 plus root 5 is equal to a, wherein a is a rational. A is a rational number. Okay, that which means it can be written in the form of p by q. Now let me keep root 3 on one side and take root 5 to the other end. Right? And then I would have to square on both the sides. Squaring both sides. So when I square both the sides, I would be getting root 3 the whole square is equal to a minus root 5 the whole square. So 3 is equal to a square plus 5 minus 2 root 5a. Okay, let me take 2 root 5a to one side. So 2 root 5a comes to the LHS part, and a square plus 5 minus 3 goes to the RHS. So now you have a square plus 2. Okay, so 2 root 5a. Now, what is root 5 equal to? 2a goes to the denominator. So, a square plus 2 divided by 2a. Okay, so if you take a is rational, right? If a is rational, a square will be rational multiplied by rational, which is also rational, right? So this happens to be rational. 2 is also rational. 2a is also rational. But root 5, we know that this is irrational. So irrational number cannot be equal to rational number. Okay, which makes, you have to write, which makes our assumption wrong. And what did we assume? We assumed that root 3 plus root 5 is rational. So this assumption is wrong. Therefore, root 3 plus root 5 is irrational. Hence proved. Okay, so this is how you have to do it. This particular method is called as contradiction method. Okay, so this is how you have to do it. Let me again explain it to you. So when you have to prove that root 3 plus root 5 is irrational, or it could be any two numbers in this in place of this. First, we will assume that, let's assume that the given numbers are rational, and let's denote it by a, wherein a is rational. That can be written in the form of p by q. Let's take any one known irrational to one side, take the other number to the other side. So a minus root 5, you have to square on both the sides. So when you square root 3 the whole square, you get 3. A minus b the whole square, a square plus b square minus 2ab. And then you rearrange the terms and simplify, solve it to a way that in LHS you have an irrational. All the other terms are making up to rational. Rational by rational is also rational. So we finally conclude by saying that irrational cannot be equal to rational, which makes our assumption wrong. Therefore, root 3 plus root 5 is irrational. Please try this once, and this is a very good question. So next question. Show that 12 to the power n cannot end with the digit 0 or 5 for any natural number n. Always remember one thing, okay? The prime factorization of a number ending with 0 or 5 will always have 5 as a prime factor. I will write it down for you. The prime factorization, this is a point to be noted. Prime factorization of a number ending with 0 or 5, ending any number, okay, any number that ends with 0 or 5 will definitely have 5 as a prime factor in it. So when you do the prime factorization of any number that is ending with 0 or 5, 5 will always be one of the prime factor. Now, but what are you given? You are given 12 raised to the power n. You can write 12 as 4 into 3 is 12. 4 I can write it as 2 square multiplied by 3 whole raised to the power n. So when you open the brackets, so a raised to the power m whole raised to the power n is nothing but a raised to the power mn. Okay, you can multiply the power. So this is nothing but 2 square whole raised to the power n. 2 raised to the power 2n multiplied by 3 raised to the power n. Okay, so the prime factorization of 12 to the power n contains only 2 and 3 as a prime factor. It does not contain 5 as a prime factor. So 12 raised to the power n can never end with 0 or 5. So you have to write the sentence. Let me write it. The prime factorization of 12 to the power n does not contain 5 as a prime factor. Right? It's only 2 and 3 that you can see here. Therefore, 12 to the power n can never end with either 0 or 5. Okay. So, for any number to end with either 0 or 5, for any, when you do the prime factorization, 5 will definitely be one of the prime factor. And if you don't see 5, that means that number will never end with 0 or 5. Okay, you can try it yourself. Check it for 1000 or 100, right? 2 5s are 10, 0 again, 2, 25, again 5, 5. So 100, if you see the prime factorization, 2 square into 5 square, right? Yes, if you take 105, right? 3 3s are 9, again 5. Again, 5 7s are 35, right? See, 5 is one of the factor. Right? So similarly, any number which is ending with 0 or 5 will definitely have 5 as one of the prime factor. Okay? So, do remember this. Let's move on to the next question. So, this is how you have to represent this question. Okay? Let's move on to the next one. On a morning walk, 3 persons step off together and their steps measure 40 centimeter, 42 and 45 centimeters respectively. What is the minimum distance that each should make so that each can cover the same distance in complete steps? Now, so you have to understand this question first of all. So each of them, the step length of the first person is 40, right? And then the step length of the second person is 42 and 45. What is the minimum distance each should walk so that each of them can cover the same distance in complete steps? So the minimum distance, will this distance, that the number that is asked by you have to think whether that number is less than the given number. Can it be that the minimum distance that each one should cover is 30 centimeter? Is it possible that they have to cover 10 centimeter? It's not possible. So what you have to know is the required answer. The required answer is bigger than the given data. Okay, what is the minimum distance each one of them should walk so that they can cover the same distance in complete steps? So definitely the distance that they have to cover, even if their step count is 40, 42, 45, what is the minimum distance each one should walk so that they can complete the same distance in complete steps. So the given answer is definitely great. The required answer is greater than the given data. And whenever this is the case, you have to find the LCM. LCM of 40, 42 and 45. And how will you do it? 40, you can take the prime factorization. It is 8 5s are 40. So 2 cube into 5. For 42, right? 42 is nothing but 6 sevens are 42. So 2 into 3 is 6. 6 sevens are 42. Again 45. 3 square multiplied by 5. 9 5s are 45. Therefore, the LCM would be the highest power of each of the common factor. So let me make it common. Here it's 7 raised to the power 0. Here it is 2 raised to the power 0. Here it's again 7 raised to the power 0. Here it's 5 raised to the power 0. And here also it is 3 raised to the power 0. So I'm just making sure that the common factors are spread across, are uniformly available in all the three numbers. So for 2, what is the highest factor? It is 2 cube. For 3, the highest factor is 3 square. For 7, the highest factor is 7, highest power. And for 5, highest power is 5. Correct? So it's 8 into 9 into 7 multiplied by 5. So 8 5s are 40, right? 40 multiplied by 9 7s are 63. So 4 3s are 12, 25, 2520. The unit is centimeter. So they'll have to walk a minimum of 2520 centimeter. Why? Because the given data is in centimeter. Right? The given data is nothing but this is in centimeter. So the answer is also in the same unit. The minimum distance that each of them should cover, okay, such that all the three are covering the same distance in complete steps, that is 2520 centimeter. Okay, always make sure you identify whether the answer that the question is asking you, whether it is greater or whether it is less than the given data. Okay, the numbers that are there in the question refers to the given data. The value that you are asked to find, that is the required answer. Always understand this, that if the required answer is greater than the given data, go for LCM. If the required answer is less than the given data, go for HCF. Okay, so with this, it will really simplify the way you do word problems. Hope you understood. Let's move on to the last question. Prove that root P plus root Q is irrational where P and Q are primes. Okay, again, let's go with the contradiction method. So for contradiction method, the first thing is, let's assume that root P plus root Q is rational. Right? Then you will have your root P plus root Q. Let it be some variable A, where you have got A is rational. And rational means it can be written in the form of P by Q. Let us keep root P on one side, take Q to the other side. So A minus root Q. And then immediately we'll square on both the sides, squaring both sides. Okay, so you have root P the whole square equal to A minus root Q the whole square. So P is equal to A square plus Q minus 2A root Q, right? A minus B the whole square. Okay, make sure, so this here, right, you have a root in this term. So make sure the root term is in one side. So I'll have 2A root Q is equal to A square plus Q minus P. Right? P and Q are all rational. Now let root Q alone be left on LHS side. Take everything 2A to the denominator. So you have A square plus Q minus P whole divided by 2A. Again, here if you see, each of this A square, we assumed A was rational. So A square is also rational. Q is also rational, P is also rational. All of these are rational terms. Rational by rational is also rational. So all the entire RHS is rational. Okay, root q is irrational. An irrational term cannot be equal to rational term. You have to write, this is not possible. This makes our assumption. This makes our assumption wrong. Therefore, root p plus root q is irrational. Hence proved. This is how you have to do it. It's a very must question in your chapter 1. So a variety of this question exists in both NCERT and Exemplar to prove irrationality. So the whole of chapter 1, real number, involves only 3 topics. Predominantly 3 topics. The first one is your LCM, HCF, the fundamental theorem of arithmetic, and the word problems using LCM, HCF, and the last one is to prove irrationality. So these are the 3 main topics from which questions are normally asked, and you have to try and solve every question of NCERT and Exemplar. I think I have completed all the exercise problems of NCERT and Exemplar of chapter 1. Do check out the playlist. I will be continuing this series for all the other chapters, the next chapter being polynomials. If you like my video and if you are able to understand it, please do consider subscribing and do like, and please write a comment so that it motivates me. Thank you so much for your support. Happy learning. Thank you.